Hello, hello. Welcome to Thinking Fast and Thinking Slow, adopting the streaming first mindset. My name is Denny Lee. I guess I'm the host today, and I want to welcome my friend Scott Haynes, who is a distinguished engineer at Nike. And so, hey, this was actually Scott's brainchild, so I want him to go ahead and actually explain to everybody what are we doing here today? What are we talking about, and what's the context, the purpose of today's session?
Yes. Why we're here that's a very, very large question, but
Oh no, I wasn't trying to get all esoteric and abstract here. I meant specifically the session, not the meaning of life. So I apologize.
for sure.
Apologize for not clarifying that.
That's all good. I think today it's basically trying to teach people like the difference between kind of what we're used to with batch and what it actually takes to get into streaming kind of first. Like, and streaming first is essentially just building streaming applications instead of building batch applications. And we can walk through the nitty gritty of all of that as well. But in a lot of cases, the concepts and things that are required to be able to run batch applications, we can simplify a lot of that by taking the streaming first approach as well. And so we can dig into that as we go through, over the next 30 minutes as well. But essentially, if nothing else, want to show people how to switch from a batch kind of perspective to that's streaming first as well.
Oh, okay, perfect. Okay, well, so since I guess let's start off with the fact that both of us are coming from both a Apache Spark and a Delta Lake perspective, right?
Yeah.
So some folks are going to go ahead and say, hey, well, I might think of this slightly differently with Trino or Apache Flink.
Mm-hmm.
But a lot of the concepts we're going to talk about today are actually applicable. By the way, even for Apache Iceberg and Apache Hootie, so this is not specific to Delta Lake or Apache Spark, but we did want to call out the context that both of us are, Spark contributors, maintainers, Delta Lake contributors, maintainers. So yeah, we're going to come probably with a slight bias into that perspective. But this is applicable to all these other systems. So, and then the other context I wanted to provide was that a lot of where the context is coming from in terms of the source of these systems is Apache Kafka, right? So maybe you're using Kinesis or Event Hub or something else, system like that. But we're, so when we say Kafka, we're typically thinking from that perspective. Okay, so all right, so then let me dive into the first question. And when we're talking about streaming data, like it's natural to think about in terms of like time, specifically near real time or real time. And how does that time change our perspective when you're talking about streaming from especially from your perspective here?
Yeah. So I think that's like the big differentiator between traditional batch is the fact that with batch you're going to go back and you can reprocess from kind of any point in time. When you're streaming, depending on the way that you're streaming, so for example, if I want to basically have a near real-time stream, I want to have things processed in under 5 seconds. I have to think a lot differently about the way that I'm going to be processing this data. So rather than having like a finite batch, we've got these unbounded streams of data. And so unbounded means it has no bounds. It continues forever. It continues until we actually shut things off, right? And so the way that we have to think about that is like, a lot of it is like that, it's a different kind of perspective. So a different like vantage point into the actual system that we're writing, that we're building. If we have 5 seconds to get something right, that means that an outage that takes 10 seconds, we're already delayed by 2 intervals that we're expecting to actually hit. And so the way that we write our applications have to be a little bit more kind of we have to write error proneness into these applications as well, because of that time. So I think the hardest part when going from batch to streaming is that you're doing essentially the same operations, but you're doing it faster and just more often, right? And so that's where kind of like that notion of like micro batching comes in, where we're used to batch. So a micro batch, still a batch, it's just continuously coming along. It's like a bunch of, if you ever seen like those big cargo trains that go on forever, that's the same thing, with each train being essentially just, this container for a bunch of information. And just goes on forever. And sometimes you're stuck sitting there waiting for it and you're mad at it. But in the case of
this This seems oddly specific, by the way, Scott. Did this happen to you recently?
I was up in Portland waiting, and there's a very large train that goes through there. I don't know which Trans-Pacific or something else like that.
Oh, was it like near the Columbia River Gorge, like that type of that setup?
Possibly. I'm bad with things, and I.
Okay. And I'm also recognizing, unless you're a Pacific Northwesterner, this is not the interesting part of the conversation. So my apologies for
we can move away from trains and we can get back to data as well. But I think the biggest thing is just
that's a good idea.
Yeah, time in general is essentially the big differentiator between going from batch to an actual to actual streams.
Okay, so you talk about the context of timing, time within the streams, but what's inherently different though when it comes to processing that data, right? Like you said, batch versus micro batch. Like, are there concerns about memory utilization, concerns about CPU utilization, how to structure the micro batches? Like, I'm just curious from your perspective, what are the sort of the top things that you're concerned about?
Yeah, so I think with that, like, it kind of comes down to like it's the way that we control how fast or how slow. So going back to like the thinking fast and thinking slow, it's essentially just an analogy to the way that we write these applications. So anybody who's familiar with like, any streaming source or any really source within like, the Spark ecosystem, for streaming, you have essentially ways of throttling. So if I'm thinking about Kafka, I've got like max offsets per trigger. I've got max files per trigger for Delta. And there's ways of essentially controlling how fast and how many records we could possibly ever process per micro batch. So if you think about that as like a finite amount of data that you can possibly read, being able to tune that helps you tune, cluster utilization and everything else as well. But on top of that too, you also have, if you think about, CPU bound versus IO bound as well, there's going to be a lot of cases where you're going to be essentially more IO bound when you're running streams than being essentially CPU bound. Like in batch, you're going to read a ton of information. It's going to sit in the executors. There's going to be a lot more kind of things to process, especially if you're reading like an entire day, entire month, entire year worth of data. But with stream, if you're essentially saying, okay, like every minute we're going to basically pick up the next million records, process them, next 100 million records, and we're going to process them. It's a lot more finite. So the control over, how much CPU you need, how much RAM you need, is essentially something that's a little bit more tunable, but also typically it takes a lot less CPU, a lot less RAM to actually process in micro batch with streaming than it does to do those kind of gigantic or like, horrendous, massive amounts of data set, like with a typical gigantic batch job.
Got it. Okay. So actually I'm looking at LinkedIn. Actually, this actually is a good, segue actually to the next part, to what originally was going to be my next question. And so Owen from on LinkedIn has noticed that you don't need a stream first unless you actually have a streaming service, right? Most people don't need video, don't need games for streaming. And while I do agree with that assertion, I think there is a context that might be a little bit missing here, right? That even though you covered it in the beginning, let's restate that before we go into diving into this context, which is when we talk about streaming, are we saying it has to be real time, or are we thinking about it from a slightly different context?
Yeah, that's a good question. And so in general, yes. Like you're going to have typical kind of SLOs that are going to be attached to like a streaming pipeline. And for a use case where you don't need to stream, but you still want to honor like memory, CPU boundedness, let's use Delta, for example. If I've got, if I've got many different Delta tables and each Delta table has a certain number of transactions, per transaction, we're going to have a certain number of like add files that are going to exist. So each file is going to have a certain number of records. Based on the layout, the schema of the actual table itself. So if I wanted to go and reprocess like a day's worth of data, I can do that in many different ways, but I can also do that like while honoring like the same triggers that you would have for streaming. So if you think about like incrementally processing a day's worth of a lot of data, you can still do that with the same kind of stream using like a trigger. And so like there's trigger available now. And if you already have all the data, it's already available. It will just basically honor the way that things are actually basically, how things are chunked and processed. And so
Right.
for some of those, gigantic tables that, are not necessarily needed for real time, you can still process things in the same way where like the state is actually controlled through the checkpoints of your application versus that state being something that you're feeding into, your different, DAG processing framework. And so it can be easier to process a lot of this data while thinking about how to process it in stream without worrying about needing it, immediately. The biggest thing with stream is usually like, an event submitted and we want to reduce the delta between the time that that event submitted to the time that it's available for any kind of analytical processing or, inference, anything else like that as well.
No, makes complete sense. And let's see, I was looking at, oh right, there's a cool little comment on LinkedIn from Sorov. He was saying in the upcoming years, streaming process will be a main part of the retail chain. Streaming has a much more advantage than batch, and I think you're right. I think you've sort of covered that context, right? Which is basically, should we go ahead and when you think about streaming, it's not just about that real time processing, though. Of course, you can't. As Scott called out, this idea of like running available now, right? So that way you're having a smaller amount of CPU utilization, smaller amount of memory, smaller cluster to process the data as it's incrementally coming in, for sake of argument, because the data got loaded into, we're going to use the example of an S3 bucket, right? So basically available now. Goodness gracious, I'm trying to remember I would always get confused with that and the old school version of that.
The trigger once or anything else? Or?
Yeah, trivial available once. I used to play with that all the time, right? So that's like,
that one,
wait, no,
that one always had like
available now. It's not. Yeah.
Let's say that one always had like that sad trumpet sound because you're like, it's like trigger once. It's like woo.
Yeah, exactly.
It's like,
Yeah, exactly.
Yeah.
But no, sorry. You can tell I'm old. Okay, but the context is because of the fact that we have trigger available now, it allows us to go ahead and process the data as it's coming in. And then actually, there's a really cool little call out. I want to see here. Is it from? Also from Sorov, actually, is that he called out that Databricks autoloader does that same concept. And that's exactly right? The autoloader basically, in effect, takes the data from, it looks at the SQS, when S3 basically alerts via SQS, what files are available. And basically, that is the thing that does trigger available now that allows structured streaming to go pick that up. Okay, so
I think that's also a good way to, if you think about that too, it's a great way of never processing the same file twice. So
exactly,
the exactness guarantees are different.
Right. Okay. So let's think here now. All right. Now, saying that with what we've said in terms of this idea that we are processing data and it's not required for just purely streaming scenarios, I guess the question that I'm wondering about is like, what are some of the strategies then people should apply when they're shifting from this to the streaming first mentality? All right. And again, remember, just as a reminder to provide context for everybody here, just because it doesn't require us to do real time or near real time. We can just do batch processing. Okay. So the question is, so even if we're doing batch processing or real time processing, what are some of the strategic strategies or change in your thinking that you should do? Because after all, Scott, you've done this a tons of times, and not just your current employer, but many employers prior before, where you're just running streaming left, right, and center. So I'm just curious, what are some of the tidbits that would be helpful for this audience here, for everybody here?
Oh, for sure. Yeah. So I think so for me, like it's kind of a different. I think I got to streaming a lot differently. The first jobs I ever worked on were based on like Apache Storm and Kafka back when I was.
Oh my goodness, yes, Yahoo, we're going back now.
Way back in the day, and so I never really worked on like traditional batch until after working on like as like some of the first kind of pipeline engineering work. And so if you think about like kind of like the reverse of that, right? Where if I had been doing batch my entire life and then it's like, okay, I need to go and move to, streaming, there is a different way of looking at that. Like, I think it's very popular to be able to write, a lot of batch jobs as like, procedural SQL, or to do things as like, procedure cascade within like a notebook, because it is an application. It's just not necessarily bounded in the same way that you would like a traditional kind of, software artifact, right? And so I think some of the things that, again, that become a little bit more tricky are like, the semantics of your application. And so if I want to write a streaming application, and let's just call this like this is trigger, processing time. We expect this job to run forever. There's different kind of things that have to be thought about, right? Where the application must be able to be shut down and start back up without any data loss. You should be able, like, if you think about, right, like a traditional, CI/CD pipeline, you're going to have an application that's running. You've made changes that are going to do something different. That's going to then go out, and you're going to have this kind of crossover where one app is basically shutting down, another app is basically spinning back up. It's the same app, right? Just one's been upgraded. It's doing more now. And so one of the hard parts, we haven't really talked about the state store or keeping stateful aggregations in place. We don't have to. We could go into that as well. But even just turning on and turning off, a prior application and just moving to the new one, there are things that you want to be able to control. And that's kind of where this notion of if you think about cloud storage as an example, it helped us to basically separate compute from the storage layer itself. And with a streaming application, you want the ability to get rid of, you want to be able to separate your configuration from your actual application as well. And so being able to not necessarily have, magic configs sprinkled through your application, but having, little kind of levers and knobs that are config driven also helps when you're, releasing new applications as well. Or even if you're just trying to find what's a breaking point for this application? At what point do I run out of memory? Do I know if this is production ready? Is this stable or not? So if you think about kind of chaos engineering, a lot of the things that you would do for chaos engineering is also something that's nice before an application goes live, especially if it's a mission critical application. And so we can also go into that as well if we want to talk about the configurations and.
Actually, let's go backwards a little bit, because let's go from a higher level, just because there's already some good questions on LinkedIn and YouTube. But before we even dive into those, why don't we talk a little bit about chaos engineering? Because some people are not familiar with that context. And I'd love to hear your perspective of it, because all the systems you've built basically have that entire basis in mind right from the get-go. So I'd love to start with that, actually.
Yeah. So I can talk about stuff that we did back in the day, at Twilio. And so chaos engineering, sometimes you plan for it and sometimes it just occurs. So it's natural chaos versus planned chaos. And so back in the day,
I love the idea of the context of planned chaos. That sounds like my entire life. But anyways, I digress. I apologize.
No, this is perfect. There was an issue back in the day. So this is taking us back to Spark 1.6 days with the first Kafka direct stream. If I had, so say I had a Kafka topic that had 8 partitions. I bumped the Kafka partitions to 16. I've got a Zookeeper file that still only has a record of 8. If I want to now start actually reading and not losing data, I have to manually go in and update the actual Zookeeper configuration to continue to move forward. So unplanned chaos is how do we know when things are going wrong? What are our expectations, right? And so it's sort of the same thing. If you think about firewalls or anything else like that, it's kind of common for people to think about, turning on and off specific rules for IP tables, to be able to say what happens if my downstream goes offline? What happens if my Kafka brokers go offline? What is my application doing? Does it fail? Is it retrying? And so in the same way that you would apply, strategies to API design, you can apply similar strategies as you're testing. So if you think about a game day, right?
Sure.
What happens when the source goes down? What happens when we accidentally destroy, accidentally destroy, right? What happens if we push an incorrect, schema change to a Delta Lake table and break our downstream?
We truncate the whole thing. Yeah, exactly.
Yeah.
Got it.
Oopsie, right? How do we rewind, right? What does that process look like? How do we reduce human error, because we're error prone, especially when we're getting paged? And so it's, if you've gone through these, these tests, right? Trials, tribulations, everything else like that, it becomes easier for you to be able to, not skip a beat when things go wrong, right? Well, a lot of this kind of goes back to those SLOs too, right? So in the initial use case, it's if we have to continue landing data every 5 seconds, then every 5 second, increment really matters. So by the time you get paged, you're probably behind by 20 intervals already. If you have to then go and triage, debug, figure out what went wrong, you might be behind by hours, depending on the source of that data. Say it's Kafka, and you've got like a very, very small like delete policy. You might start losing data, and then what happens, right? So it's much better to go through a lot of exercises to be able to break your application as best as you possibly can, so that when it actually happens, you don't have to struggle as much. If that makes sense, right? It's what's possible. Also, if you're monitoring, the behavior of your application, you also know what symptoms to look for. Am I continuously processing? Am I getting throttled because I basically have a straight line and I've got specific input and output rows per second that never really achieve a higher mark than some potential throttle? How do I know how long I'm lagging? Like the list kind of goes on, and it's easy to be able to get into those situations through planned chaos.
Right. Okay. So without diving into cliches about basically every plan breaks when reality hits, right? I was trying to be not overly military with that particular phrasing. I love the fact that basically from the standpoint of you starting, like whatever you develop, you basically plan for the fact that there could be things going wrong.
Yep.
All right. So now let's talk about the wrong. And so we've got some great questions. Actually, they're starting to pile in. So we got to catch up on these. So let's dive into these. And these are all great questions. So let's start with Broth's questions on LinkedIn. And we also have some questions YouTube, by the way. So Broth had first question. He's got two of them. So when you're reprocessing data for whatever reason, like bad data, bad ETL, whatever, right? How do you think about reprocessing from a streaming mindset, right? Because in the case of batch, we're like, that's okay. Let's just go batch it. And then we just kill the batch and, undo the transaction for sake of argument.
Yep.
With streaming, you have a little bit more data, right? So let's dive into that question first. Like, what's the change of mindset or the thing that you have to take into account of, especially from that chaos engineering perspective, just because it'll be absolutely normal for that scenario to happen, which is bad data, bad ETL, bad something. So how would you normally do it?
Yeah. So I think for part of the stuff, right, it depends on the application and how many downstream customers you have for that data as well. So let's say in a case where something goes wrong, I'm just going to draw with my hands. It's like, let's just imagine, right? So imagine a world where we have this initial pipeline that breaks. Right. So we've got, who cares, right? It's a forking garden of many possibilities of these downstreams. Right, but as long as we are degrading in one spot, it's a lot easier to actually go and fix that. So I think part of this question is, if we know that something is corrupt or we know something is broken, do we catch that before or after the fact? And so if we are doing, if we're doing proactive scanning, like Spark expectations, Delta live table expectations, if we know that something isn't right and we're able to stop that ahead of time, that makes replaying a lot easier, because everybody else is just essentially waiting on our next transactions to occur. And if they don't have to all there's this whole it's like this, the butterfly effect of when things go wrong within like a streaming ecosystem. If we can stop the butterfly effect, and essentially we're fixing this kind of one span within the system.
Right. So let's dive into that just one little tidbit. Sure. So in other words, whether it's Spark expectation or DLT expectations or whatever you're using, right? Yep. The context is, and please correct me if I'm wrong here, right, is that since we have with the next set of an expectations, we say, hey, we're expecting this schema or values of a particular range, the correct data type, whatever else, right? And so because of that, the idea is that if we know that the data doesn't match those things, then boom, we automatically push that to a staging table or to a errors table that can be reviewed at a later date. So that way, the data that goes in there is actually clean or meets our expectations.
Yep. So
then there shouldn't be an error. Or did I cover that correctly?
Yeah, you covered that correctly. It's kind of like if you think about like a dead letter queue, right? It's like we know this is bad, we're going to put it somewhere else. But to the other point too of like, how do you actually go back and do your replay?
Right.
There's like, if you think about like, I have an application, my application has checkpoints. If I'm able to basically fail a specific transaction before it completes,
Right.
then I shouldn't have anything that's problematic. I should essentially just be continuously retrying and things keep on breaking as I go. I'm going to continuously kind of throw errors. And so
Okay.
in that case, it's like, it's a waste of, it's a waste of overhead. It's a waste of compute, but at least we're not, going anywhere else. We should be getting paid when these
Sure.
things,
Okay.
I think, say things do go wrong, but somehow, magically nothing else goes back downstream, but we need to go and reset, right, to a point in earlier time. That's where I think it gets a little bit more tricky, right? So if I think about this in terms of just, a Delta Lake transaction, if I know that I'm on, currently a transaction 100 for the, for the sake of this conversation, I need to go back to transaction 90. So 10 transactions that occurred beforehand, something got corrupted between, 90 and 100. We don't know where. And so now that's now our objective to go and figure out what happened. We're going to have an upstream in this case because something corrupted. Something is corrupt. It's either an upstream where these things occurred, where the problems occurred, or it's a change in our actual application code. And so as long as we're able to kind of, do, root cause analysis to figure out what occurred, then we can, use time travel for Delta Lake to go back to an earlier, transaction, just restore our table to that point. And then we're now going to basically fill in the blocks of what was corrupt. And then we can continue to, happily send everything else downstream. The larger issue where we kind of poison the well and send bad data downstream is a little bit more tricky, right? Because if all of those other downstream applications are also streaming applications, then we're going to have to blow away checkpoints. We're going to have to then rewind. And so like with Delta, we can use the starting version or starting timestamp on the source to get back to the transaction before things went bad. And it gets like, we can stop there for now because things get a little bit more complicated as well. If we have, partially corrupt aggregations and we want to go back to rebuild that aggregation, because we'll have to blow away, a lot of state potentially, depending on how long an aggregation, what's the vantage point of an aggregation? Is it hours? Is it, days, et cetera?
No, perfect. Yeah, since we have lots of questions, we'll stop there. But hey, Bharath, since you asked the question, hopefully we've provided enough context of where we're coming from. And then for everybody that's listening today, if you would like Scott and myself to actually go even deeper to concepts like this, please let us know. Okay. Carly's going to send out a questionnaire form for you to fill out. So that way you can dive in and provide those questions. We're going to record all these questions as well. So that way we can actually use this because this is a regular series that Scott and I are going to be doing. And we're going to have other guests as well. But the context basically is that if you have these questions like this and like to dive deeper, let us know. So, and vote, by the way, those questions. So that way we'll actually try to start tackling them actually. Okay. So just as a call out. Okay. So, just go to the next question, since we've got about 10-15 minutes left. Louis has asked a great question. He said, hey, he saw a case where with AWS SQS is trying to manage the retry of information and sometimes would fail. So SQS would try to go to the S3 bucket and try to reprocess again. Would you recommend this practice? And what other good practices would you for retrying? There's a little bit of a call out to autoloader here, but without referencing the Databricks autoloader in this case. Yeah, let's just dive into that specific question.
Yeah, so for SQS, I am not as familiar with SQS. So it's more, my background is essentially more in like the Kinesis Kafka, like for stream processing.
Honestly, that's good enough for this purpose. Like, so don't forget, the SQS is just basically the one that's you've got two choices. You could talk from Louis' perspective. We can talk about from like basically S3 file gets into S3, it gets loaded into SQS, number one, or number two, you actually use SQS to process the data. In this particular case, I'm pretty sure he's referring more to SQS is processing the data, which is fine. Then let's just talk about from a Kafka / Kinesis perspective, because at least fundamentally it's the same concept.
Yeah, I mean, with that one, like with the retries, right? Like there's lots of different ways to approach the same sort of problem. The hardest part is if you're looking for kind of a needle in a haystack of, of corrupt data, for example. With Kafka, it's a lot harder to figure that out, right? You've got specific offsets, and it's like which offset from which partition of the topic, did something break, for example. Same thing with S3, right? You might have a subset of all the new files between the last time you processed and when you processed that's causing a problem. And so in certain cases, like if you're just trying to figure out what is corrupt, this kind of goes into more of like, Spark native land. But you have like this notion of like permissive pass-through. And so if I'm in permissive mode, I will allow non-corrupt data from these transactions to be read, while also kind of quarantining the actual rows of information that are problematic. So I can go and try and figure out more information from there as well. So like if I think about like a Kafka data frame, I'm going to have all the information, the topic, I'm going to have the partition, I'm going to have even the timestamp to understand when something did occur. And I'm also going to have my value column, which is going to be binary. It might be a string, whatever else. I need to be able to try and, deserialize that information from that row of information to get the data that's either corrupt or not corrupt. So at least like in like that, the Kafka use case, you've got all pointers to go back and attempt to triage, but then things get even more complicated, and we could do an entire series on that as well. But let's say for a simple example, we have one upstream writer to that Kafka topic. So therefore we know that a change has occurred upstream, and it's a lot easier to figure out that, this one team or this one process introduced some issue, right? It might be like we used to have issues with like double byte characters, and things could get corrupt because of like non-UTF-8 encoding. And so there's problems that basically sneak up on you. But being able to use the metadata for each transaction is a great way of being able to go back and at least isolate the problem, right? If you don't understand where to start, it becomes a lot easier. It becomes a lot harder. It becomes a lot easier. It becomes a lot harder to actually figure out like root cause analysis, especially if you're on like, when you're on the clock, right, as well. So it's like, you kind of get into that split brain mode where it's like, I know I have to figure this thing out. I need to get this job back up and running. And so like the last part of this, I think that's important too, is that like in a lot of cases, while you're managing to figure out what was corrupt, if you have the ability to continuously, if you can push data forward while figuring out what was broken before, and your downstream use case doesn't really care too much, like say it's looking at like every 5-minute window, and it's okay for it to lose a couple minutes of that window, then you can essentially create an application that's using like offsets latest that continues to push data forward while you're actually trying to figure out what's wrong. And at least there's new data going, and then you can go and like do a replay afterwards for other people. Like it really depends on the use cases, but that was a strategy we used to have at Twilio when things would go wrong, where you'd start the application with new checkpoints, running off of latest, so that things would continue to stream through the system while we were kind of going back and backtracking to figure out what went wrong, fixing the application, plugging a hole. Like if you think about Kafka, you've got starting and ending offsets. So you can run a batch that will fill in a very finite space, and then you don't lose any data. It's still harder to actually go reprocess at the end though, but it's manageable.
Cool. No, super helpful. All right, let's try to continue diving questions. Now we're going to switch over to YouTube. Dustin's actually asked a really cool question, which is one thing he'd like to understand better is introducing the context of data set management, the optimized compaction in the midst of your streaming first mindset. So how do you actually deal with the fact that you're actually trying to do like basically table maintenance at the same time as data's coming in? And great question, Dustin. Thank you very much for asking.
Yeah. So I think with this one, like you have like you've got auto optimize, which is one way of adding your compaction. It's like, I think it's right now, what is it? It's like every 10 transactions, you'll optimize in process for a stream, but you also have like write optimize as well. And so it's like, if I'm going to go and write my transactions, I'm going to actually go and do compaction to take care of like the small files problem before my transaction is essentially kind of complete, so that any downstream would have, essentially like taking a step back, it's fairly, one of the things that I've done in the past is, sort order by timestamp. So that it's a lot easier to go and read everything within a batch without having to do any kind of sorting. And so it's like, what are the guarantees of the upstream to the downstream? And so if the guarantee is that everything's going to be like sequentially correct and then compacted, it saves everybody else a lot of downstream processing time. So it's like we we bite the bullet with time. So kind of going back to the initial time concept again. It takes time to go and do these operations. So where you could, be kind of blindingly fast, minus a little bit of a buffer so that you're not creating a small file problem, you're going to basically bite the bullet at one point where you're going to go do that compaction. It's better to do the compaction once than it would be to have everyone else worry about trying to optimize the data set as they're going to read it. So depending on the total number of downstream consumers, like it's, n compaction jobs per downstream consumer, right? And that's a lot more expensive. And so really it's just a trade-off, right? It's a trade-off on speed to make sure that everything's faster downstream.
Or trade-off on time. Sorry. Sorry. And my apologies to anybody who's a Doctor Who fan. I probably you can't see my Doctor Who poster, so my apologies. But okay. As I digress, but one thing I did want to call out, another approach, for example, when you're looking at these massive systems, right, which Scott has created, and I have, I've debugged my fair share. Let's just put it that way. Okay, so a common approach basically is to also run a second job, which its whole life is basically to compact, right? To basically, like, so you have all these little small streaming files. And for example, in Delta Lake, and this is any Lakehouse format has a version of this particular problem, by the way, is that you have now a lot of little transactions in your transaction log, and you've got a lot of files, right? So the whole point is to then have a second job. Doesn't need to be as big, but basically its job is to then compact. So let's just say you, fun scenario, partition by hour. Okay, just because you have that much data. Then once the hour is done, no problem. Go ahead and compact the hour's worth of data. So you've got a lot more smaller files. And then in the same time, compact your transaction log. Well, after you words, of course. So that way you don't lose any transactional consistency. But the idea is you compact or vacuum the transaction log so the transaction log doesn't get nearly as big. Right. So there are these other strategies that come in play that will allow you to basically deal with the fact that you're wanting to understandably maintain or optimize your table at the same time as you're actually streaming data into it. So yeah.
100%.
Cool. Oh, by the way, a little call out from Claire on LinkedIn. She's remembered the good old Twilio days, so I think that was a shout out to you, Scott. So just wanted to do a shout for that. All right, we've got probably time for only one more question. So apologies for everybody that has actually asked some really good questions. We're gonna try to make sure, like I noted before, we're gonna actually save all the questions, and that way for the next session we'll make sure to answer them, and we'll ping you even too. The fact that we're doing it, but sure. The last one that we probably have time for, and then we do a little shameless plug for our book, because I forgot if we didn't mention that right in the beginning, but Scott and myself are basically co-authors with Tristan and Prakash and our Tyler Croy. We're the co-authors of Delta Lake Definitive Guide. But anyways, as I digress here, how do you easily handle two streams of table, like when you're doing a join between those two? Like basically a streaming table as it's coming in and a stacked table join, right? Also, right? So let's just talk about the first one, which is like you have two tables that are kind of streaming in. Actually, no, let's do the easier one first. One table that's streaming in and you want to do join to that. How do you typically handle that particular scenario?
I mean, I think stream static joins are easier, right? So if you think about like a static table, we can make this more complex as well. Like, is the static table up to date? If it's not up to date, what happens, right? Right. So there's different strategies for it. I think like if you think about just kind of classical like structured streaming, then you'd have all of your data coming in that needs to join against something, right? And so if that something is a static table, you're either going to have a record that lines up, right? Like I'm going to have something to join against. Right. If I don't, then I'm going to not have anything to join with, and I'm going to be sad. It depends right on the style, right? If you're doing right join, left join, if you're doing like full outer, etc. Like there's different sort of semantics to that as well. So it all really depends on like, what is it that you want to do, right? If you think about like the use case where it's like, I'm essentially testing to see if something exists, right? You have you have essentially like an anti-join type pattern. If you want to say like, what doesn't exist? Like I want to be able to like quarantine these. And so like, there's a couple different use cases for being able to do, processing where you have an expectation that you'd have 100% coverage on the static table that you're joining. And so we could go into those semantics. We only have 4 minutes left.
Yeah, we only have 4 minutes left.
We could take this one offline. We could even put this into like the GitHub discussions as well for Delta Lake. So I think
that's true. That's good.
This is a good one. But stream static is a lot easier than stream. So like with stream, you're essentially like, you have to be concerned about like how long to wait, right? So if you're doing stream with aggregates, you have watermarking. And so if something just doesn't exist, great. Eventually, you'll just never have anything to join against, right? So you've created these kind of like orphan joins. We'd love to be able to go and, it's a weird analogy, right? But like, essentially, if we have like this orphanage of data, like that's essentially what happens when stream fails. We have either, data that's been picked up by the other stream because we have an actual record on both sides, or we don't. And if we don't, then it's up to us to figure out what we want to do with that. Like, again, going back to Twilio, we used to have something called our orphanage. And so data that couldn't be joined would actually go into the orphanage and we'd pull things back out of there as well. We called it an adoption process, right? Where it's like, I want to go adopt this data once I have something that can join to, but it really also depends on the semantics, right? So do you have the time available to go back and essentially ensure that you have 100%, 100% join rate? And then if you don't, then what's the fallout of that as well? Because stream, you have to wait around. And so depending on like, the end-to-end SLO, you might have, 15 to 20 minutes per side of the stream. So 40 minutes plus, watermark interval, et cetera. So you might have up to an hour to get all the data right. And so that's when things become a little bit more problematic. So if if the other streaming, if one of the streams that you rely on is also having an outage, then that stream is getting no new transactions. And so depending on the join, that also might mean that your job is not running as well. And so it becomes a lot more complicated. There's different methods and ways of doing a lot of this work as well. Like you could go into like, go into like a CDC table, or you can create like an intermediary state table where you're essentially always looking to go and do a join for things that haven't joined before. But in general, stream is good if you don't need an exactly full join to occur. Otherwise, if you always need everything to exist, then that kind of goes back into batch land for that as well, because the streaming is just not going to cut it for that. So that would be, a con of stream first as well for that.
Makes complete sense. All right. So let me go ahead and present my part of my screen. Oh, sorry. Okay. Well, let's see if I'm actually doing a good job on sharing a screen here. Oh, here we go. Okay, perfect. Okay. So, for starters, just as Scott called out, there's a lot of really good questions, and we're actually getting some really good feedback from right on LinkedIn and YouTube. So we're going to go ahead and try to be a little bit more structured going forward with some of the questions that our people are asking and providing a little bit more context. So for starters, go ahead and use our GitHub discussions. We actually created some discussions right here already in delta.io/delta/discussions, where you can actually chime in with your questions. So we can actually start going ahead and not only answer the questions here, but during these webcasts, we can go ahead and provide a little feedback and context as well. Hopefully that'll help out. The second thing, and then this is, I freely admit the fact that I'm doing a shameless plug now, which is, here we go. If you go to delta.io today, and you simply scroll down to around halfway or so, here we go, Delta Lake, the Definitive Guide, and click on download, you can get your own copy of Delta Lake, the Definitive Guide book for free. This is the PDF version. You can just download it. We have forwards by Michael Umbrust and Dominic Brzezinski, so pretty cool. And the final little tidbit I want to shout out is that we actually have an AMA, Ask the Authors, ask us, ask the ATA, Ask the Authors, excuse me. And that's happening on the 26th, I believe. And I think Carly or Scott, keep me honest, but I believe that's scheduled
That's right.
for the 26th.
Yep.
Okay, perfect. And so, again, we have questions whether it comes to streaming, about what's going on in the book. By all means, join us for that as well. So, saying this, I hope everybody's had fun for today's session. Please continue providing us feedback, what you like, what you don't like, so we can go ahead and make this a fun experience for everybody. But that's it for today. I really appreciate your time. Hopefully, we'll see y'all on the 26th when we dive into Delta Lake, the definitive guide as well. Thanks very much. And Scott, thank you very much for today's session. Really appreciate your time, man.
Cool. Thanks, dude. This has been fun.
Awesome. Thanks very much.
Bye, everyone.
Take care, everybody.